Okay, so for years, GPUs have been the undisputed kings of AI. I mean, nothing else even came close. But what if their reign is about to end? There's this company that just put a brand new kind of processor in a German supercomputer. And get this, it doesn't even use electricity to compute. This could fundamentally change everything we know about high-performance computing.
And the numbers they're throwing around are, well, they're wild. The company claims these new chips give you a 3,000% boost in efficiency over a normal GPU. 3,000%.
Oh, but it doesn't stop there. Nope. They're also talking about a staggering 5,000% increase in just raw compute power. Look, we're not talking about small, incremental bumps here. This is a revolutionary kind of leap. So, the big question is, how is that even possible? How do you get numbers like that? Well, the answer is kind of simple, but also really profound. You just stop using electricity to do the math. You use light.
Okay, but before we get into how this new light-based stuff works, we really have to understand why it's so important. And to do that, we need to look at the old king of the hill, the GPU. GPUs are amazing, don't get me wrong, but they are slamming headfirst into a massive physical wall, especially with the insane demands of AI these days.
It really boils down to two huge problems that are holding everything back. First, there's something called the memory wall. And second, you've got this ugly pair, extreme power consumption and the crazy amount of heat that comes with it. So this memory wall, what is it? It's basically this growing gap between how fast your processor can chew through numbers and how fast your memory can actually shovel those numbers to it. It's like having a world-class chef who has to wait for ingredients to be delivered one at a time. And GPUs, with their total dependence on VRAM for AI stuff, are super vulnerable to this. It's a crippling bottleneck. And then there's the heat. This is where it gets really interesting, because it all comes down to basic physics. Think about it. If a GPU sucks in, say, 500 watts of electricity, where does all that energy go, right? The calculations create information, but information, well, it isn't a physical thing. It has no mass, no energy. So by the laws of physics, every single one of those 500 watts has to get dumped out as waste heat. And this is where the new tech comes in and does something that feels like it's straight out of science fiction. Instead of fighting a losing battle against the heat from all those moving electrons, this new processor just sidesteps the problem completely. It computes with light. Now, this next part is the core idea, and you gotta wrap your head around this because it's a little bit of a mind bender. With this technology, the physics itself is the math. You're not telling transistors to flip on and off to get a result. You are literally manipulating the laws of physics to become the result. So forget about billions of tiny silicon transistors. At the heart of this thing is a special crystalline material, thin-film lithium niobate, if you want to get technical. And your data isn't a stream of electrons, it's a laser beam. A laser beam that this crystal splits and bends and tweaks. And here's where the magic really happens. With a GPU, you're basically using brute force, right? Flipping millions of transistors over and over again. But on this chip, you just shine light through it. As the light waves cross each other, they create these interference patterns. And that pattern is the answer. It's not calculated, it just is. The math literally solves itself at the speed of light. So let's just lay it out side by side. GPUs use brute force with transistors. These new photonic processors, the physics just solves the math instantly. In a GPU, electrical resistance creates a ton of heat. But photons, they have no mass, no resistance, no heat. The takeaway here is huge. Right where GPUs are hitting a hard physical wall, this new approach just elegantly sidesteps the entire heat and power problem. All right, I know what you're thinking. This all sounds like some crazy science fiction lab experiment that we'll never actually see, right? We hear about stuff like this all the time. But this is different. This isn't just a what if. It's already out there, being put to work. Yeah, this is not some prototype sitting in a lab bench. This thing has been packed into a standard server, and it's installed and running right now at Germany's Leibniz Supercomputing Center. We're talking about a world-class, top-tier data center. It's real. But you know, amazing hardware is only half the story. A huge reason NVIDIA dominates is its software. So how do you get anyone to actually use this new chip? Well, you make it super easy. For starters, the hardware just slots into a normal PCIe server slot. But the really brilliant part is the software. They built this bridge, this library called QL, that lets developers write their code in standard Python and PyTorch, the stuff they already use every day. The library just invisibly translates everything into light for them. Developers don't have to become optical engineers, which is key.
So, let's recap. It's way faster, way more efficient, and it's easy to program. It sounds almost too good to be true, doesn't it? And, well, it turns out that when you compute at the speed of light, you run into a brand new and frankly very weird bottleneck that I don't think anyone really saw coming.
Yeah, before we start writing the GPU's obituary, we have to address the massive elephant in the room. Because this amazing new technology has one big, potentially fatal flaw. And that flaw has a name: the conversion penalty. Here's the deal. These photonic chips are wizards at calculating, but they have zero ability to store data. They're all processor, no memory. So all your data, all the AI model's weights, everything, it still has to live in good old-fashioned electrical memory, like VRAM. And that means for every single calculation, you have to take electricity, turn it into light, do the math, and then turn the light back into electricity to store the answer. And that creates this painful latency loop. You're constantly going back and forth. Pull data from VRAM, convert to light, calculate instantly, convert back to electricity, store in VRAM, and you do that over and over and over. Now, if your AI task needs a ton of memory access, and let's be honest, most of them do, all that converting back and forth can completely wipe out all the incredible speed and energy gains you just made. So, is this thing a dead end? Is the fatal flaw actually fatal? Well, not quite. There's a pretty clever workaround for right now, and then there's a holy grail solution that everyone is racing to build for the future. The solution for today is to use these things as highly specialized coprocessors. You don't use them for everything. You aim them at very specific jobs. Think massive scale climate modeling or super complex medical imaging. Basically, tasks where the calculation part is so huge and intense that it makes the conversion penalty look small by comparison. But the real prize, the end game that labs are working on, is something called a photonic latch. What is that? It's basically an optical version of SRAM. It's computer memory that stores data using light. Just try to picture it. Microscopic little loops of light right there on the chip, acting as an ultra-fast cache. If you can do that, you never have to convert back and forth to electricity for those quick memory hits. You would completely, totally solve the conversion penalty. And that brings us to the final really big question. If, and it's a big if, but if they can figure out how to scale up this photonic memory, if they can create a single chip where light can both compute and remember, what happens to the GPU's absolute monopoly on the world of AI? The future of computing might just be, well, a whole lot brighter.